ahead and record it. Cool. All right. So with that said, for everybody who attended, despite midterms happening, thank you so much and welcome. So BITS has a really exciting event today with a close mentor of mine, a good friend. So we're basically going to witness a live demonstration of natural language processing via machine learning with Joe. So if you guys have any questions during this walkthrough about data science, machine learning, anything like data related, Joe has a bunch of industry experience about it. So please drop them in the chat. And once we get to Q&A, he'll go down the list and answer as many as he can. So without further ado, I'll just hand it over to Joe. I'll stop sharing. And Joe, if you want to share your screen, introduce yourself, that'd be great.
All right. Let me share my screen. Okay. Can you see my screen?
Yep, perfect.
Awesome. All right, so my intention with this presentation isn't really to get super in-depth on NLP, but I will be showing a quick demo and a couple use cases. NLP itself is an enormous field, so we're just going to kind of scratch the surface and just kind of show you what's possible. I'll start with a short introduction as to who I am. I'm kind of like a hybrid data scientist. I do strategic pricing and machine learning. So my background is in econometrics and math. So I kind of shifted into computer science naturally from there. I work more on the business side. I'm not a purely IT data scientist. I'm kind of a mix. Prior to this position, I was a lead data scientist in consumer goods, and my main role was AI-based pricing. I also do some consulting on the side, and my specialties are process automation and quantitative modeling. So kind of like econometrics, time series, things like that. I'll kind of start this off by telling you what the most important skill of a data scientist is. So I speak to a lot of data science managers and directors in the industry. And the most important skill, and the one that's lacking within a lot of data scientists, you'll be kind of surprised at, and that's communication. A big problem within the data science field is a lot of data scientists are very, very technical, but they can't communicate why they're doing what they're doing. And with this kind of demonstration, I'm hoping to A, give you the code, but B, kind of give you the intuition and show you why we would use something like this. And just a couple more things that are lacking among data scientists today, obviously communication skills and business acumen. A huge one on the technical side is SQL. It's actually pretty surprising at how many data scientists can't really use SQL, including myself. I'm not that great at it, but I have been forced to pick it up. And software development skills. We'll talk about this more when I show you the demo, but software development is an extremely important skill within data science. The Pareto principle, I'm sure you guys have heard of the 80-20 rule. So 20% of your job, maybe even less, will be analysis. The other 80% will be understanding and cleaning your data. This goes doubly so for natural language processing. Human language is very complex. We have a lot of intricacies in the way we talk. One very easy example is sarcasm. It's very hard for a machine to understand sarcasm unless we have the context. And then this is kind of a secondary thing, but 20% of your explanatory variables will usually give you like 80% of your output. So anyone that's worked with regression analysis, 20% of your variables are likely to make up the majority of your variance. Here's kind of a high-level view of my process when I work with machine learning. This is the slide before we actually delve into NLP. First, you need to identify the business need. You build a proof of concept. So I'll show you both of these in this presentation. You'll create kind of a non-technical value-driven presentation. Again, communication skills. And you get the right people in a room. And then after that, you'll build and deploy. But those are kind of the easier parts. 1 through 4 are the harder parts. So with that short introduction, we can kind of delve into NLP. So what is NLP? Natural language processing. It's a field of computer science. Some linguists will say it's also, a field of linguistics. The field It was invented in like the 60s, essentially, but it's seen an enormous resurgence in the past decade. So this has been around for a while. And if any of you have kind of read about machine learning, a lot of these techniques, they're old. They're from the 60s or the 70s. We just haven't had the computing power to use them. And now we do. So here are a couple tools. Obviously, Python and R are the biggest ones. We also see a lot of Julia and Java within NLP. And for the deep learning, we have PyTorch, which is Facebook's kind of deep learning library, and TensorFlow is Google's. Some quick definitions. This is the only definition slide, I promise. It's very basic, but we'll be using these definitions as we go. So tokenization, essentially you take a sentence, you split it into constituent words. They're called tokens. Standardization, kind of what it sounds like. You make all the text the same. So remove periods, remove commas, remove certain formatting, make everything lowercase. This helps a lot in the long run. A corpus, we're going to be working a lot with, I think it's called corpi, the plural. Don't quote me on that, but it's essentially just a self-contained collection of text. A book is a corpus. A news article or a bunch of news articles is a corpus. Stop word, these include like the and a, basically words when they're isolated, they don't really mean anything. We usually take stop words out. N-grams, string of n words that appear together. So once we remove stop words, which words appear together the most often? And regular expressions, this is basically a concise kind of piece of code that summarizes patterns. And we're actually going to talk about regular expressions because odds are you've seen these before. So here's kind of a simple email identifier, and this is kind of the syntax for regular expressions. Essentially what we're saying is we look for a string that starts with one or more alphanumerics or symbols. We look for a literal at. Same thing again, one or more alphanumerics and then a .com. Here's kind of a Python implementation. It might be a little small. Let me know, I can zoom in, but this is a 3-line implementation. The first line is the pattern, kind of what I showed you. It's a little more robust than what I showed you, but not much. The input, you can see that it has 2 email addresses in it. So it's got joe.m@mydomain.com and then joe.business@biz.com. Then we can just use a Python library to find that pattern in the string. And right below it is the table that we get. And I'm going to talk a little more about software development as we go, but this is really easily breakable. And here's how. All we have to do, instead of the at symbol, we have an at in brackets. People will often put an at in brackets. They might have a typo. If you look at the second email in the string, there's a space before biz. So that's a very easy way to break this regular expressions. With NLP, we can build more robust kind of parsers, or we can even just build something with regular expressions if we're good software developers. So now the kind of fun part, the machine learning. So here are a couple of use cases. This isn't my visualization at all. I found it online, and I thought it has some good points, but I will talk a little bit about how hiring and recruitment is a very dangerous kind of segment for NLP. But I'll also be talking about sentiment analysis and chatbots. So now I'm going to shift to a live demo, and I'm going to show you the wrong way first. So here's kind of my code. I'll show you high level. So we have 3 main portions. We'll import the data, and then we're going to filter it to the first 1,000 rows. No real reason other than my computer isn't that strong. And I'll show you the data right now. So here's kind of the data. Actually, I'll make it right here. Here's the data set. We have the review. So this is an IMDb database of just reviews. It had 50,000 reviews in it. Now it has 1,000. It has pre-labeled sentiment in it. And here's what we do after we process it. So you see, we've kind of made them lowercase. One thing we're going to do next is remove these quotation marks. We're going to remove, exclamation marks, things like that. So that's the high level. It's just movie reviews. We can do a couple of visualizations. I'm sorry if this takes a little while. It is a little bit slow, but here's a high level. This is the most basic thing you can do. It's a word cloud. Basically frequency on size and color. You can change those around. That's no problem. That really depends on your preference. Same thing, you can't really see the text, but this is basically the word cloud in bar chart form. We can make a bar chart with word frequency. And then I'm going to show you kind of what we can do with sentiment analysis. So right here, we're importing a library. It basically does, it's got a bunch, it's an API. It gives us a bunch of things that we can do with text. And I'm going to talk about all of these things later, how they work. But for now, I'm just going to show you the code, and I'm going to show you the right and wrong way to do it. Okay, so now we have the sentiment DF. So you'll see that it's similar to our original data set, but it's got a couple differences. So we have the sentence right here. And what we have it now is we have a polarity, which is basically how negative or how positive is the review, subjectivity, and overall sentiment. So this overall sentiment, it's controlled by this parameter we feed right here. So for very negative or very positive, if it's either negative 0.5 or positive 0.5, it'll be very, otherwise it'll be slightly. So this is where kind of the context comes in. You're gonna need to, as a data scientist, you're gonna need to look at these these parameters, and you're gonna need to decide how to adjust them accordingly. You see that when we actually run this, we only have like 10 very positives out of 1,000, and that's unlikely to be true. We might need to adjust this 0.5 somehow. But the ones that are labeled very positive, they do seem to make sense. So real and surreal all in one. Very positive, pretty subjective, it makes sense. What a surprisingly good movie. And then if we look at the negative, we don't have any very negative, but I kept watching it because it seemed like the plot was going somewhere. So that one, it makes sense. And that's very interesting because this kind of reads, if you read it word by word, it reads like either a neutral or maybe a positive review. But once we incorporate all of this kind of machine learning, we can get the actual sentiment. Okay, so that's kind of the wrong way to do it. And the reason it's the wrong way to do it is because when you look at my code, I'm doing one thing per line. There's no functions, there's no classes, it's very inefficient. So here's kind of the better way to do it. So I'll rerun this. And now you see, instead of these lines right here where we take the processed review, we make the processed review this kind of regular expression, then we do it again with this regular expression. We have a function that does that. So now if we ever need to do it again, we can just run this one line of code with this function and we'll get the same exact results. Same thing here. So this is our word cloud one. So now, it's one line of code. We can get basically the same results. And there's actually a better way to do this, which I will show you. But this is kind of like, this is what you should aim for when you're developing these programs. And then you can take it a step further and think like a software developer, which we'll get into. So far, I only really showed you sentiment and visualizations. Now I'm going to show you topic analysis. And I'm going to go over how this works. There's a lot of ways to do topic analysis with machine learning, but the one we're using right now is called LDA. And for those of you that do study machine learning, it's not latent discriminant analysis. It's actually a different thing, another LDA within machine learning. But we get these 3 topics. They're not great, but for a 1,000 row data set, they do seem to make sense. So they're saying like they liked it, but the characters were bad, good time, So you can mess around with the number of topics and the number of words per topic to kind of optimize your algorithm. Another thing we can do, and I'll kind of go over how this works as well, but we can predict topics. So this requires a pre-labeled data set of topics, which I don't have, but what we're going to do, instead of pre-labeling the topics, we're going to use the sentiment as a makeshift topic, purely because, I didn't have the time to pre-label 50,000 reviews, but in a perfect setting, you would have kind of someone doing that, and you would be able to label these topics. And I'll show you kind of the accuracy on that too. So for now, we're pretending that positive or negative is our topics, and we're going to see how well our model can classify these. And while that loads, it will take a little while. I'm going to show you kind of the right way to do this. This is the best way to do this. So I will, wow, one sec, I just closed it. Let me, OOP approach right here. Okay, so now what we've effectively done is we've taken that entire visualizations block, made it 3 lines. And we've effectively taken that entire topic analysis block and we've made it 1 line. And how we did this is, for those of you that know Python or any kind of object-oriented program or language, we've kind of abstracted it within this class called text stuff. And an actual software developer will probably say that's a horrible name for a class, but that aside, this is kind of how we would handle it. So our constructor takes in the argument of a text list and the data frame. And then from there, we'll process all of these. We have a bunch of these kind of classes. One is manipulation, one is analysis. So from there, we can run this entire program in just 3 lines of code. And I'll talk about kind of the advantages of taking an OOP approach later. Let me open the right one. That's the one we were working with. So we're at topics prediction. So now we can actually look at our accuracy. So that's pretty good. So even without legitimate topics, we just had positive and negative, almost no manipulation of the data out of the box. We can label our data, our topics, which is basically our sentiment, 73% of the time correctly, which is way better than randomly guessing. And this is just the sentiment block. So that's pretty good out of the box. Usually, if you're working with this kind of data, you'll probably be manipulating it quite a bit. You'll probably spend a couple days just understanding the data and how to manipulate the data properly, and the context and the business use case. And one thing I did want to kind of touch on with this, the right way to do it, is this, we can get, if you remember, we had those like cutoffs for very and slightly for our sentiment analysis. Here we can define them within the function. So this makes it a lot more reusable. So whenever we run this function, we can, or we can make, we can change these polarity cutoffs, and we can make something like a for loop to loop through a bunch, like a list of parameters, and see which parameters give us the best results. And that's something you'll be doing a lot as a data scientist. You'll be kind of testing hyperparameters and what gives you better results on your train and test sets. So that's kind of the high level view of the code. Let me go back to my PowerPoint. So thinking like a software developer, it's all about reusability. You don't want to be copy and pasting a bunch of code from program to program. As a data scientist, you'll have a lot of projects that you'll be balancing. So having these classes that you can easily leverage and just import into your new program is very, very crucial. So there's a couple really important reasons why we need to be good developers. It makes you very versatile as well. So you can not only tackle data science tasks, but you can also tackle data engineering tasks or software development, troubleshooting. So it gives you like a much, much bigger skill set. One thing I didn't really mention in this demo, and it's a huge topic, but model deployment. So when you deploy a model to the business, you need to abstract basically everything. You need to abstract all of the data sciencey stuff and give them a nice, pretty interface. And that's kind of how you get buy-in. You need people to actually like the interface and understand what you're doing. And to do that, you need to build very good software that people can use and use it easily. Efficiency and reusability, I kind of went over that, and it just looks better. I mean, if you look at this example, on the left is the way I call the right way with the functions. And then on the right is once we just abstract it all with that class that we made called text stuff. So it just looks better. And when you have errors, you can easily trace it to one of the classes and one of the methods within the class. Same thing here. We abstracted this entire topic analysis code block to one line of code. So now I'm going to kind of go into how these methods work. So under the hood of sentiment analysis, there's a bunch of methodologies. All of them have pretty varying complexities. And I've said this before and I'll say it again, context is the most important thing. When you're a data scientist, intuition is extremely important. I feel like within kind of the mainstream media, we hear a lot about how crazy machine learning is and how we can automate the jobs of humans, but it really isn't that. It's not that easy. You need the business. You need to understand the data. You need to manipulate the data. Everything needs to be done by a human. If you apply the best in class algorithm on a terrible data set, you're going to get very bad results. And you'll see that as you work with more and more data sets. You can have the best algorithm, the best software, but garbage in, garbage out. That's basically what it is. So here's kind of the naive way of doing sentiment analysis. So say you have a sentence on the top left. The NLP presentation on Thursday was great. First thing we'll do is we'll remove the stop words, so words that don't really mean anything like the and on. We could remove was, and then you can kind of choose which words to remove. If you have, so for example, with the IMDb data set, you might want to remove movie because movie is brought up in every single review, or maybe film or something like that. So, the context plays a role in here, but for now, we're just going to remove stop words. We're going to tokenize it. So you'll see number 2 in the middle. We have now kind of a vector of tokens. And now what we're going to do for those of you that kind of know SQL is we're essentially just going to left join it with something called the lexicon. So Microsoft has a sentiment lexicon where they have thousands of words, and if they're positive or negative words. And then you're basically left joining that in and looking at the ratio of positive to negative words. I'm sure most of you can already see the issues with this. For one, sarcasm. It's very hard to tell sentiment when someone's being sarcastic. If you say not great, it's very hard to understand not great as negative versus positive, because not will be neutral and great will be positive. So the lexicon approaches miss a lot. One thing that we do within the NLP community is we'll use something called bags, like a bag of words model. So say we have this corpus on the left. What we'll do is we'll take every single word within the corpus and make one column out of that word. And from there, we'll say, is it switched on or switched off in each row? So row 1 represents the first sentence, row 2 represents the second sentence, and whether or not each word is switched on or off in that sentence. And as you can probably see from here, we can start looking at frequencies in a much better way. But we still have a couple issues. So for example, if we didn't purge movie or film from the IMDb database, the relative frequency of those can skew all of the results. If you've worked with any kind of statistical modeling, some outliers can have enormous leverage on your results. So one thing we can do is we can use something called a TF-IDF. It's a term frequency and inverse document frequency matrix. It's essentially rescaling your data to kind of lower the weight that common words have on your information. I won't go into the math of it. It involves a little bit of like logs, but if you want to look it up, feel free. The math is on Wikipedia even. And then from there, once we kind of do that manipulation, we can feed this matrix into a ML or deep learning model. And depending on your use case, you could do some kind of classification task. You could do some kind of quantitative modeling task. But right now, this data is in the best form for machine learning. Machine learning works best when you have kind of a matrix like this. So a little bit about deep learning. For those of you that haven't really worked with deep learning too much, it's basically kind of like neural networks, any kind of transformer models, which we'll talk about a little bit later. Essentially like machine learning on steroids, but there's a little bit of a black box component to it. You don't really understand, or you can't really interpret why the machine is doing what it's doing like you can with something like a random forest. And because of this, it's very hard to explain to the business. And for those of you that have worked with like business units trying to explain data to them, you'll know that once you lose them, you've lost them completely. Like they won't buy into your idea. So what you need to do is you need to make these presentations so that they understand them. And using deep learning is definitely not the way to do that. If you work for one of the big tech companies, you'll probably be using deep learning a lot. Well, not a lot, but a decent amount compared to other companies. If you're working for a mid or small company, chances are you probably won't even touch deep learning because it's just, at this point, it's not really worth the effort. And then within the statistics community, there's something called Occam's razor. I mean, this expands way more than the statistics community, but within stats, we like to say that the simpler the model is, the better. If you can lose maybe 3 or 4% accuracy using a much simpler model, use that simpler model. So now I'm going to kind of talk about LDA, and that's what we use to generate those topics before and label those topics. LDA is essentially a generative model. It uses probabilistic distributions to generate values, and then using probabilities, it gives you the topic. It's very useful for large amounts of text, though it is very computationally expensive. And we'll pass a corpus like we did before. Each line represents one document, or one sentence, one news article, whatever you want it to be. But the corpus contains a bunch of these. So a little intuition behind it. Given we pass some corpus to it, we can describe any document as a distribution of n topics. So within each document, there's a distribution of n topics, and within each topic, there's a distribution of m words. So within each document, there's topics, and within each topic, there's words. And here's kind of a visual. So this is how modeling would look if we are just modeling with words. So from article to word. There's a lot of overlap. Like for example, flying cars are driven by cats. That's the last one. And then the first one is dog is an animal. Dogs are loyal. These two can be mapped to the same topic, even though they have nothing to do with each other, just because they have animals in them. What happens when we use LDA is we'll take each document, map it to a topic, and then within each one of those topics, we'll map them to words. And then using kind of like frequency tables, we'll be able to label each word with a topic. So what exactly does LDA mean? For those of you that have worked with advanced statistics and you know of the beta distribution, like a Dirichlet distribution is essentially the multivariate generalization. So it's the beta distribution in 3D. And I want to kind of shift your attention to this middle one with the box around it, the triangle. You'll see that it has 3 kind of red points at the tips. And this is kind of how LDA works with topics. So imagine each one of those is a topic. So imagine it's animals, sports, and tech. You'll throw each word in there, and each word will be kind of pulled in a direction. So maybe, let's see, maybe Olympics is 90% sport and 10% tech. So then it'll be kind of pulled toward the sport direction. And you'll do that for every word, and then you'll do it also for every topic within the documents. This is just kind of a high-level formula. Again, I'm not going to really go into the math. Honestly, it's pretty complex, and you can probably have a couple lectures just on this algorithm. But I just kind of wanted to show you. It's essentially at its core, it's a conditional probability. So what are the odds that this is an animal topic given all the other words in the corpus? A couple takeaways. Again, it's a set of distributions, and it's used to segment topics. And here's kind of how you use it intuitively. So you'll pick K topics, and you'll assign these topics to each word just randomly. For each word, assume it's the wrong topic, but all the other ones are right. And then you'll kind of adjust the probabilities based on that. And there's a hyperparameter within the algorithm where you can tell it to run through the data set n times. And so you can do this throughout the whole data set and then repeat it again for the whole data set and then repeat it again for the whole data set. It's very, very computationally expensive the more you repeat it, obviously. And here's kind of the way the output actually comes out. The way I had it, I kind of abstracted it a little bit, but you'll have these kind of probability scores. And those of you that have worked with regression, it's kind of like having beta coefficients within a regression. You'll have like, 0.6 to great, 0.44 to presentation, et cetera. So these are probability scores by word frequency. And what we can do with these probability scores is once we add a new document to this model, we can actually predict its topic. A couple current NLP challenges. I kind of touched on this before, but emotions and sarcasm are huge. It's very hard for a computer to tell. Context, computation. So when we have these enormous data sets, I'll actually talk about some other methods and how computationally expensive they are. And then detection of fakes. So there's actually a lot of papers on this recently that basically they show you how scary the field is and how scary reviews are, because you can essentially make a simple algorithm in like 20 lines of code that just strings words together and they seem like a readable, legitimate review on like Amazon. And it's very, very hard to detect these reviews from real reviews because they look so real and they're very simple to make. And kind of on the topic of context. So if I were to like kind of tell you the sentence, I saw furry X sleeping under a tree, you as a human, you already kind of understand, you're already inferring the shape of the animal, something about the animal's attributes. But a computer cannot do that. And that's where the human comes in. You need to kind of train your model to understand these relationships. And each data set is very different, and each industry is very different. So now I'm going to come back to this use case chart, and I'm going to talk about why I think hiring and recruitment is very dangerous as far as NLP goes. So OCR is inconsistent. OCR is basically taking a PDF or a Word file and transcribing it so that a recruiter doesn't have to read through it. OCR can't read everything. It'll botch a lot. Even the best in class OCRs will do that. Google has Tesseract, and we built like a deep learning model for it, but you'll see very often it'll botch a lot. So a lot of skills will be misinterpreted, or purged even. So OCR is inconsistent. Another thing about NLP and hiring is some things are unquantifiable. Things that you see on a resume may not necessarily be the holistic view of a candidate. And the way the industry has been moving is that they're trying to have their resume summarize the candidate. But you can't really summarize something like soft skills or communication skills on a resume. It's very hard. So that's one other danger of bias within hiring. And we've seen this a lot. We've seen that training on the majority actually leads to skewed results. And people are way more complex than we like to think. We're not very simple. A computer can't just predict our mannerisms. So kind of applying these NLP algorithms on just resumes and trying to get a holistic view of a candidate is very dangerous. This link right here, it kind of talks about how we can start removing bias. Some of you may have heard about Tay, which was Microsoft's bot that was basically influenced by the majority to be racist. So that's kind of a very good example of how when you put like kind of a majority that isn't indicative of the whole into an algorithm, it'll skew it immensely. And that's kind of what we can see with NLP and hiring. So transformers. This is the state-of-the-art methodology for NLP nowadays. So I'm not sure what experience you guys have with deep learning, but I'll just give you a high-level overview. Previously, we used to do NLP with recurrent neural networks. Essentially, what we're saying is before neural networks, we were just looking word by word. We couldn't really tell you like this sentence means this because it was looking word by word and we couldn't really understand what happened before. With recurrent neural networks, if you look on the bottom left, that's kind of a high-level diagram of how a neural network works. You have an output, you feed that output into the input. So every time you're kind of feeding an output into the input, so your new output is based on your old output. So that kind of helped a little bit with context, and it helped with kind of summarizing larger amounts of data, but it was still kind of incomplete. It can look back a sentence or two, but it's not going to look back, one page to what happened, a couple pages ago. Transformers have really revolutionized NLP. A transformer think of it as like a neural network, but way, way more complex. A transformer uses something called attention, in that it has a couple recurrent neural networks built into its architecture, where it will essentially probabilistically choose what to forget based on kind of these hidden layers and hidden scores. So it's meant to act like a human. You forget what you don't need, you remember what you need, and you feed that into your new input. BERT was kind of the algorithm that paved the way. It's an enormous model trained on the entirety of, I believe, Google Books and Wikipedia. So it's a huge model. It kind of paved the way for transformers as well. It's still used widely within the deep learning community, but it's not really accessible to the average, person in business. The main reason is the bigger model is like 32 gigabytes in RAM. The smaller model is like 16. So you need a supercomputer just to run these models because they're enormous. Other than that, I mean, as I said, deep learning is very complex and the use cases are often not worth it. GPT-3 just came out pretty recently. Essentially an enormous model like BERT. It has capacity for 175 billion parameters or neural networks, so it's huge. You basically need like a whole server room to run it. Microsoft has the API key, but it controls the source code. It wasn't made by Microsoft, but I believe they acquired it. It's trained on 300 billion words, and it's mainly used to predict the next word, just like BERT. So that's kind of the overview. I mean, NLP is an enormous field. You've got so many different, facets of the field. What I showed you is just a small, part of it. And as you kind of learn more about the field, you'll also kind of see like how complex and how fast it's growing. But some closing thoughts. One thing I would definitely recommend if you want to get into this field or maybe some other, field of data science is learn to code properly. It'll go a long way. It'll definitely help you streamline how long you work on projects. Understand the business, hardest part. Make meetings with, other business units, understand their data, understanding their pain points. Network kind of, goes in line with the previous one. And data science is a huge field. I've touched on this, but what I showed you is the basics of NLP. And I'm not an NLP practitioner. I mainly do quantitative analysis. I do build out NLP pipelines, but kind of at a high level. I'm not, that PhD computer scientist that's working with BERT all day. Data science is a huge field. You'll very often feel like an imposter. You'll very often feel like you don't belong because, you don't know how to use BERT, or you don't know how to use GPT-3, or you didn't read this most recent, paper on AlphaGo. And in reality, most data scientists, the vast majority, are specialized and have a certain skill set. They're not jacks of all trades because it's impossible to be jacks of all trades because the field is enormous. So, focus on one thing, learn how to code properly, and then, just understand the business. That'll get you a long, long way, and understand the context. So, Ranesh, you let me know. I actually have, it's not NLP, but I do have another demo that I can show. It'll take like 2-3 minutes, kind of
Yeah,
showing.
absolutely.
Okay, sure.
Yeah, that'd be great.
Sure. And this is basically illustrating how within the machine learning community, we try to go for the simpler model. So let me actually load my environment then. So, and I'm actually going to show you a little bit of deep learning. Very, very basic. Not very highly tuned or anything, but just high level, basic. All right, let's just open Spider there. One sec. But I'll give you a little bit of background on this. So within data science, like with a lot of the other technical fields, there data science hiring managers are kind of moving toward a like take-home test method. And this was actually one take-home test that I was given. And I was just going to show you, this actually gave me a senior data scientist offer. So I'm just going to kind of show you what it takes just for one of these take-home tests. I'll show you the data. So we have the high-level data. This is the train set. I had no idea what the variables were. They don't really tell you. Obviously, you would want the context, but it's biomedical data at a high level, completely abstracted, dummy data. You have a bunch of these. You can already tell that this unnamed one is probably just an index. We can remove that. And then you have a validation set that you test on. This validation set does not have this variable called curve call in it. So we're trying to predict curve call. And actually, this program got 100% accuracy. So first thing we'll do kind of like a high level correlation matrix. First thing you should always do is visualize your data. We look at if there's any kind of high correlation between the variables. We'll deal with any NANs. We'll either impute them or remove them. Imputation depends on context. You need to really understand your data to do that. We can look at distribution plots of all the variables, which is very important. So you see like this variable is very normally distributed versus this variable is just zeros and ones. So you need to understand your data basically. We have a method for outlier removal, but we're not going to use it because outlier removal is very risky unless you know your data. And first thing we'll do is we'll test a basic analysis. Usually you want to test the easiest, the simplest analysis you can, which is a logistic regression. So we test the logistic regression. Here's our method accuracy. So 97%, or sorry, right here, 96%. So we misclassify 6 and we properly classify the rest, which is pretty good for a simple method. Next thing we can do, we have a random forest classifier. For those of you who have worked with random forest, they're basically a cheat code. They're very, very effective. We look at this one's accuracy, quite a bit higher, 99%. And then we can predict after that. And then here would be the neural network. So I will show you the neural network. So now it's training. It's doing 100 passes. And we kind of look at this graph. Usually what you want is you want your test and train accuracy to be similar so that you know you have an overfit or underfit. We will predict, and then we'll look at the accuracy. So we see that both the random forest and the ANN perform equally well. The data set's kind of small, so you know usually there'll be a bigger disparity, but not much. We definitely don't want to go with the ANN since the results are so similar. And honestly, I might even go with the logistic regression just because the trade-off is kind of small. And again, context. So think about it this way: if lives are on the line, you would probably want an ANN. For anything else, business use cases, you know, go with the logistic because it's easier to explain, it's simpler, and there's less kind of risk. And one thing that I actually did here is you'll see that we have a couple custom classes. So right here, import classification methods. So this is an abstracted class. So this is basically a class that I made that has basic scoring, accuracy storage, and ROC, which is for logistic regression. So kind of area under curves. We also have random forest attributes. So this is another class just for random forests. And as you can probably imagine, you're going to be using these methods a lot. So having these classes is very, very, very important. So you can just, you know, pop these in to one of your folders and just import them. And you have all this code already there for you. So you don't have to rewrite all that code. And then we have these custom methods, which is basically data manipulation. Again, very, very useful. So you can reuse your code. Yeah, so again, not really NLP, but this is kind of like what you should expect when you're going into the mid-level data science interviews, because this is kind of the take-home test they'll give you. And they'll be asking you to explain your thought process and why you chose what you chose. All right, so that's that. That's all I got on my presentation. I guess we can shift it over to questions.
Yeah, definitely. That was a really cool walkthrough. So I don't like see questions in the chat right now, but I actually just had a real quick question. So
Sure.
I noticed that like the structure of your code. Oh, real quick, let me just
You want me to
share my
reshare?
screen again.
Oh, okay.
Yeah, that'd be great.
Sure. All right. So in my which one?
The original one.
The original one? Yeah, sure. So let me go. Oh, right here. Okay. Yeah.
Cool. So, like it was a little small, but I just, if you could like briefly kind of like tell us like what would be your like process of steps when like after importing your libraries, like what would you do like in a logical order in order to do a like uh a specific like task for NLP or just anything data science related?
Yeah, that's actually a really good question. So one thing I would highly recommend is either mentally or physically map out what you need to do. So have like your first steps, which is get the data, clean the data. How are you going to clean the data? Have a couple high level steps. So talk to the business and say we need to filter on this specific document type. We need to do this. We need to do that. So you get all those filters out of the way first. With
Yeah.
NLP, the equivalent of that would be getting the business to tell you maybe which words don't really make sense to leave in. So here we remove film and movie.
Okay.
We'll do a little bit of regular expressions manipulation and standardize. So with NLP, standardize, remove the words. That's always the first step. Um, with with quantitative analysis, always visualize your data. So look at correlation matrices, look at the distribution of your variables, check assumptions, because a lot of statistical methods, uh, you can't really, they have very rigid statistical assumptions that you shouldn't violate because then the interpretation gets skewed. So for example, with regression, you need to make sure your variables are a certain way. There's no
Mhm.
correlation between the x's, things like that. So
All
after
right.
you kind of look at your data, so this is kind of the equivalent of looking at your data. You look at your most frequent words, then you can kind of go to your actual machine learning. Um, I guess this one would probably show it a little better. Let me zoom into this one. So this is
Okay.
outlier removal. And then, so when I work with any kind of quantitative modeling or classification tasks, I'll always set it up so that I have a simple model, a more complex model, and then the most complex model. You can have four or
Okay.
five, whatever you want, but you definitely want to kind of you want to have something that shows you the base case. And actually, I didn't mention this, but this is the accuracy of my logistic regression. The straight line is if I just randomly guessed, so it's 50%. We call it like a no skill guess. So
Okay.
given someone just like threw darts at a board, they would probably get 50% accuracy. So
Mhm.
if we can kind of get above it, that's great. If we get close to it, then that means our model is like not great. Um,
Okay.
and
So,
yeah, sorry, go ahead.
just to clarify, like that orange line for the logistic regression, like, are you supposed to basically calculate the area under that curve, like a PMF, like a PDF kind of?
Exactly. Yep. And the higher the area under the curve is, the better your proper classification rate is, essentially. I
Okay.
mean, ideally, our model would be like a right angle. So like right away,
Mhm.
it has a 0 false positive and 100% true positive rate. Because this is
Right.
false positive here, true positive there. But we're pretty close. Like we're very
Okay.
close. Just with like a slight, kink in the graph, we get very close to 100% accuracy. So this is like a very good graph for logistic. And then after you build out these processes, you're going to start tuning your hyperparameters. You're going to start tuning like the number of estimators, the max depth, or the neural network. You're going to start tuning like right here, the neural network gives you probabilities for either a 1 or a 0. Right here, it's a simple, if it's 0.5 or greater, it's 1, or if it's above 0.5, it's 1, otherwise it's 0. We can tune these too. And the way we'll tune these is we'll do this, and then we'll test it on the test set to see which one gives us higher accuracy. Then we'll also look at this graph. If this test accuracy is better than the train, then that's a bad thing. They need to be close. So, we're going to have to balance. And a lot of it isn't science. A lot of it's just kind of intuition, and a lot of it's just kind of hoping that what you're doing is right.
Yeah.
But yeah, I mean, you get the hang of it after a while. It's like all statistics is wrong, but some are useful, essentially. So, you want to make it as useful as possible.
Okay. And just to, oh, okay. So we have a question from Jacob.
Sure. Here, let me pull it up. Can you generally explain how common NLP apps? Oh no, there's one above it, right? Here.
Yeah. Yeah.
Okay. What did you mean AI developed prices for? Does that mean you create code that sets? Yeah, that's a good question. So it's multi-stage. So within that company, we had a lot of different products and of different qualities and of different market segments. First thing we needed to do is we needed to segment the customers through machine learning, really. We would look at, people of this demographic tend to buy this product, very high level, but we would put a lot of variables into it. We would look at their buying patterns. There's a lot of like industry specific stuff that we build into those models. And then after that, we would calculate something called elasticity of demand for those of you that taken kind of economics. Um, Essentially, what drop off in volume can we expect with an increase in price? So a 1% increase in price gives us a X% drop in volume. So we would look at that per customer segment. And we would say, so like this customer segment is very price sensitive. So we need to adjust the prices accordingly. So things like that. And then what we need to do is we need to build a forecast. And the forecast was built actually using a recurrent neural network. So that was one of the few deep learning use cases I've had. So it's kind of like a multi-tiered piece of software. It needed to do everything. So from start to finish, identify the customers, what they're willing to pay, when they're willing to pay it, and what we can expect them to pay in the long run. So that's that. Let me go to the next question. No problem. Can you generally explain how common NLP apps such as Google Translate or website chatbots may use syntactic analysis? Sure. So a big thing, especially with Google, is the transformer technology that I kind of worked with. And a lot of how it works, if you put aside how great transformers work, essentially it's just using enormous data sets to say, like, usually when someone says this word or these three words, they say this word next. So it's kind of analyzing that syntax like probabilistically. So given I say NLP, I'm very likely, like 70% likely to use apps after that. So that's kind of how they, at a very, very high level, that's how their kind of chatbots work. The classic chatbot was, specific word based. Now they've kind of shifted to trying to understand that context. And it's really just through enormous data sets and recurrent neural networks that look back, or transformers that use recurrent neural networks that look back many words to try to understand that context. And you'll probably notice if you have a Google Home or something, if you try to talk to it sometimes it won't really understand what you're trying to say. So you try to clarify it. And that's kind of why, like, the way you've said it isn't very common in that enormous data set they have. But once you make it very, clear cut, then it starts to understand. And that's basically because of that whole like probabilistic model they have on the back end. No problem.
Great. So we'll wait around and see if there's another question or so. But in the meantime, Joe, before like final like statements and stuff, we'd like to get a picture with like everybody. So if everyone could like share their video, then that would be great.
Hey, we'll just wait on a couple more people and then take a picture. Okay, sorry. All right, I'll count down from 3. 3, 2, 1. Got it. I'm gonna take the next screen. Just give me 1 sec. All right, 3, 2, 1. Got it.
Awesome. Thank you, Sharia.
Hi.
So
Oh, sorry.
no, go ahead.
I just wanted to ask, is there a QR code or no?
Yeah, so that's what I'm about to do. I'm just gonna
Thanks.
share my screen really quick. So yeah, so I guess that concludes the Q&A portion. You guys can see my screen, right?
Yep.
Okay, cool. So yeah, for those of you who need the suitable real points, here's the QR code. I'll leave it up for like another minute. Apologize for the background noise.
Thank you for having me.
Yeah, no, thank you for doing this on short notice, Joe. We really appreciate that.
Nope.
I never really understood like what it would be like from a coding perspective, but it doesn't seem like rocket science anymore. So
No. Yeah, you get used to it real quick. Here, let me I'll link my LinkedIn at least in the, there you go. So you guys, if you want, you can add me on LinkedIn.
awesome. Yeah, thank you for that.
Mhm.
Cool. So I'll just hopefully everyone got the real points thing. So yeah, like I mentioned earlier, obviously midterms are happening. We're totally understanding of that. So we got like 2 pretty chill networking opportunities for you guys next week. The first one being on Tuesday evening. We have an information session with Crow. Definitely great firm. If you want to come out and get to network with the individuals, please do so. And then on Friday night, we have a Jeopardy like happy hour with the e-board. So it'll be really chill and fun. So come through for that. And yeah, before you guys head out, please take a screenshot or a picture of this slide. So these are all the different ways you can be in contact with us and keep up to date with our upcoming events or initiatives. And like if a friend of yours maybe wanted to attend like say today's event but couldn't, we upload a lot of our event recordings on our YouTube channel here, so please like subscribe and give us a like and stuff. Yeah, so with that said, I think that is it. I will stop the recording.